So today we're going to be looking at all the different forms of a quadratic function. We know factored form, and we've been using factored form a lot to solve for the roots or the zeros of a function. So factored form gives us the roots or zeros. We learned this week vertex form, which gives us the vertex, which is the h and k. And standard form we haven't really talked about this, but standard form is going to give us the y-intercept, which is going to be the c value. Just like in y equals mx plus b, the constant, the b, gives you the y-intercept here. The constant, the c, gives us the y-intercept. So there's a lot of work to do this. We can rewrite all equations into factored form, vertex form, or standard form. So taking a look at the first two examples, they're given in standard form. We're going to rewrite them in factored and vertex form and come up with the coordinates we can get from each of these. So for number one, again, it's written in standard form. So this 12 is our y-intercept, and we will write it as 0, 12. Then from here, we can write this in factored form. 12 is our product. -2 and -6 multiplied together give us 12, but when we add them, we get -8. So we have y equals x squared minus 2x minus 6x plus 12. Factor by grouping. So y equals x times x minus 2 minus 6 times x minus 2. So finally, our factored form is x minus 2 times x minus 6. So our roots are going to be 2, 0 and 6, 0. Because if I were to set each of those equal to 0, add the 2, add the 6, I would get +2 and +6 for the x-intercepts. And then for vertex form, we have to complete the square. So if we remember solving by completing the square, we're going to complete the square to put this in vertex form. So we have y equals x squared minus 8x. Half of 8 is 4, squared is 16. So plus 16 minus 16 plus the 12 that is originally in the equation. This part is our perfect square. So y equals x minus 4 all squared. And -16 plus 12 gives us -4. So our vertex is 4, -4. All right, so we get 5 points from those 3 different forms of the same equation. For number 2, same idea. This is the standard form, so our y-intercept is 0, 18. We can rewrite it in factored form. So we would want to see what factors of 18 have a sum of -7. Factors of -18 have a sum of -7 rather. So that would be -9 and +2. So y equals -x squared minus 9x plus 2x plus 18. So y equals -x times x plus 9 plus 2 times x plus 9. So y equals x plus 9 times -x plus 2. So our roots would be, if I were to set this equal to 0, x plus 9 equals 0. So our one root would be -9, 0. And if I were to set -x plus 2 equal to 0, I would subtract 2, giving me -2, and then divide by -1, giving me +2, 0. Then from there, I can put it in vertex form by completing the square. So back to the original equation, y equals, I'm going to factor out the negative times x squared plus 7x. Half of 7 is 3.5, squared is 12 1/4. Don't forget to bring down the y-intercept. This is the perfect square. So y equals -x plus 3.5 all squared. And then the -12 1/4 comes out, is multiplied by a negative, so it's +12 1/4 plus 18 is +30 1/4. So our y-intercept, or not our y-intercept, our vertex would be negative 3.5, 30 and a quarter. So that's a lot of work to go through, but you can definitely do it if you are ever asked to take something that is written in standard form and change it to vertex form, or something that's written in standard form and change it to factored form. Now for the bottom two, we're given them in factored form. We're going to change them to standard form and vertex form. So from factored form, again, these would give us our roots. So if I were to add 5 to both sides, I would get 5, 0 as one of my roots. If I were to subtract 1 and then divide by 2, I would get negative 1/2, 0 as my other root. To put this in standard form, we're going to double distribute. So y equals 2x times x, which is 2x squared, 2x times negative 5, which is negative 10x, 1 times x, which is positive 1x, and 1 times negative 5, which is negative 5. So our standard form is y equals 2x squared minus 9x minus 5. So from that, we get our y-intercept as 0, negative 5. And then we're going to complete the square to write it in vertex form. So y equals, factor out the 2, times x squared minus 4.5, because that's half of 9. 2 times 4.5 is 9. X. Now I'm going to complete the square. So I have to have half of 4.5, which is 2 1/4 squared, which is 5.0625. So plus 5.0625 minus 5.0625. Close the parentheses, minus the original 5. Now, this part gives us our perfect square. So y equals 2 times x minus 2 1/4 all squared. 2 times 5.0625, because I need to take that out of the parentheses, is 10.125. So minus 10.125 minus 5. And then our last step, y equals 2 times x minus 2 1/4 all squared minus 15.125. So our vertex would be positive 2, negative 15.125. Okay, so the last one is similar to that. Let's come up with all the different forms. We're given the factored form. So our roots, if I set 3x equal to 0, x would be equal to 0. So one of our roots is 0, 0. If I set x minus 8 equal to 0, I'd add 8 and I'd get 8. So our second root would be 8, 0. Then I can write this in standard form by distributing. So y equals 3x squared minus 24x. There is no y-intercept or no c value, so our y-intercept is 0, 0, which is given by one of the roots. And then we complete the square to write it in vertex form. So y equals 3 comes out, x squared minus 8, because 3 times 8 is 24x. Half of 8 is 4, and 4 squared is 16, so plus 16 minus 16. Y equals 3 times, this is our perfect square, x minus 4 all squared, and then 3 times negative 16 to take this last negative 16 out would be negative 48. So our y, or our vertex, would be positive 4, negative 48. So you're going to go ahead and continue on the back. Make sure you take the points that you find and graph them to show the whole function.